Now let's put all this stuff we've learned about random variables together into one problem, the coffee and donuts problem. At a certain coffee shop, all the customers buy a cup of coffee. Some also buy a donut. The owner's been keeping record of his sales and has determined that the number of cups of coffee sold per day is normally distributed with a mean of 320 cups and a standard deviation of 20 cups. So let's call the number of cups of coffee sold per day C. Number of cups of coffee sold in one day. Okay, we know that this is approximately normal, and we know that mu of C is 320 and sigma of C is 20. Okay, so that's given. Now, the number of donuts sold per day is also normally distributed with a mean of 150 donuts and a standard deviation of 12 donuts. So let's call D the number of donuts sold in one day. It is also approximately normal with the mean of the donuts sold 150 and the standard deviation equal to 12. And that looks really pitiful, so let me try that again. So the standard deviation of D equals 12. All right, now it says he makes a profit of 50 cents on each cup of coffee and 40 cents on each donut. Assuming that coffee and donut sales are independent of each other, how likely is he to make a profit of over $300 in one day? Okay, so what are we trying to find out exactly? We're trying to find out the profit. Now to find the profit, which I'll call P, random variable profit, would be 0.5 times the number of coffees sold plus 0.4 times the number of donuts sold. So we have a combination of random variables here, and they're both multiplied by a constant. So we need to know, we want to find out what's the probability that P is greater than $300, which means we need to know a distribution for profit. We need to know its mean and standard deviation. Now let's go ahead and think about its distribution. Multiplying by a constant does not change the shape of a distribution. Adding or multiplying does not change the shape of a distribution. We also know if we add two variables that are approximately normal, that their combination is also approximately normal. So we know that this profit variable is going to also be approximately normal. So we just need to know what is the mean of the profit variable and what is the standard deviation of the profit variable, so that we can use that normal model then to answer the question, how likely is he to have a profit of over $300 in one day? So let's break this down a little bit now and use our given information, and let's find what is the mean of 0.5 times the coffee. In other words, what is the mean of the total profit on the coffee? Well, we'll know that if you multiply a random variable by a constant, you just multiply its mean by the constant. So this is going to be 0.5 times 320, or $160, because this is in dollars. So $160, if he sells 320 cups at 50 cents and makes 50-cent profits on each cup, that makes perfect sense. Now the standard deviation of 0.5 C, if you multiply a random variable by a constant, it also changes the standard deviation. Addition doesn't change standard deviation, but multiplication does. So this is also $0.5 times the standard deviation of 20 cups, which means we have a standard deviation of profit of $10 on the coffee. Now let's look at the donuts. Mu of 0.4 times the donuts would be 0.4 times the number of donuts sold. 40 cents times the number of donuts sold, which would end up being $60 of profit on the donuts. on average per day. And the sigma, let's change that, make it look a little better. Sigma of 0.4 times the donuts would be 0.4, this is in dollars, times 12, which turns out to be a profit of a standard deviation of $4.80 on the profit for donuts. Now we're ready to do the big combination here. We're ready to find the mean of the profit. That is the mean of 0.5C plus 0.4D. Well, I know that if I add two random variables, it is the sum the mean is the sum of the means of the two random variables that I've added. So this is $160 plus $60, which is $220. Now, when I want to find the standard deviation of P, that's the standard deviation of two random variables added together. Now, I can't add standard deviations, but as long as these two variables are independent, and we forgot to read that part, assuming that coffee and donut sales are independent of each other, that means I can add variances. So this is the square root of $10 squared plus $4.80 squared, which turns out to be $11.09. So now we have a normal model with the mean for profit with a mean and standard deviation of $220 and $11.09. So once again, we are ready to find now the answer to the question, how likely is it that his profit is greater than $300? Now you might already have an idea about that, but let's draw the model and just kind of think about this. So here's my normal model, mean of $220, standard deviation of $11.09 for the total profit on the coffee and donuts sold in one day. I want to find the probability that P is greater than 300. So let's kind of think about where that would be. If 220 is the mean and one standard deviation is 11, that would be about 231, and then another standard deviation would be about 242, and another three standard deviation would be about $253. Oh my gosh, $300 is a lot more than three standard deviations above the mean. As a matter of fact, it turns out to be quite a bit more. We could even figure this out by finding the z-score. 300 minus 220 divided by 11.09 turns out to be 7.2 standard deviations above the mean. You guys already know that that's highly unlikely to happen. But let's go through the motions of figuring it out anyway. So if this is 300, I'm trying to find this little tiny probability here that this might possibly happen, okay? So the probability that P is greater than $300, which is the same thing as the probability of Z being greater than 7.2, we can find using our normal CDF. And I'm not going to go through the calculations on the calculator since we've done this so many times, but this would be 300 to infinity with a mean of 220 and standard deviation of 11.09, and this turns out to be on your calculator 2.74 ... times 10 to the negative 13. You're going to see 2.74 something e negative 13. That means this. That means 0.000000000000274. Highly unlikely. Basically about 0. So the question now is, how likely is he to make a profit of over $300? Highly unlikely. So according to the normal model, so assuming that all of his record keeping and computations about his profits are correct, according to the normal model, the probability that he makes a profit of $300 in one day is practically 0. 7.2 standard deviations above the mean is almost impossible. So there we have it. There's an example of using a combination of random variables, both of which follow a normal model, both of which have been rescaled. Now the only thing we haven't shown in this is what would happen if we rescaled by adding. If we rescaled by adding, it would affect the mean but not the standard deviation. Other than that, we've got a pretty good example problem for you to go by when you tackle your homework on this section.